We go. All right. Well, good morning, everybody. Thanks for sticking with us here. We're going back to back to back. We have here Elliot Crow from LBNL. He is a colleague of mine, I am proud to say. Elliot is a technology researcher leading technical research on commercial building data analytics, commissioning, measurement and verification, and other related areas. He has about a decade of utility program implementation, technical research, and training experience with his time at PECI and Clear Results. And he is also the principal investigator for the Smarter Small Buildings campaign, which is the DOE campaign. He has a presentation here called Smart Thermostats, State of Technology and Responding to Grid Signals. I will be fielding Q&A for folks to have any questions. Please feel free to put them there and I'll get to them at the end of the presentation. Elliot, please take it away. Thank you.
Thanks so much, Armando. I am going to spend a little bit of time here on the state of technology piece, just given a quick flyover of the levels of functionality and capabilities in smart thermostats. I'll give a fairly high-level overview of the grid signals piece, like the what, where, what, why, and how of that. And I'll tie some of these pieces into the Smarter Small Buildings campaign. Through that campaign, we are at your service for anything you want, whether it's demand response support around these kind of smart thermostats, or more generally, just about smart thermostats controls for HVAC in small to medium buildings. I think that smart thermostats aren't necessarily restricted to small buildings. I'd say that small to medium, let's say up to 75,000, are the kind of buildings that are most prevalently looking at smart thermostat type controls rather than a full-blown DDC building management system. And the data does show that 94% of commercial buildings are less than 50,000 square feet. That's CBEX data. And of those, only 5% have smart thermostats. That's, massive opportunity that we see in the marketplace to improve HVAC controls. In terms of the benefits, I may be preaching to the converted here, but there are significant savings on energy consumption simply by maintaining the correct occupied times and set points. So many buildings are not controlled adequately and matched to consumption occupancy. Um, Improving occupant comfort is another big piece here, and streamlining maintenance and extending equipment life. So on that third piece, we do see that is increasingly crucial. Energy costs in small buildings, for an individual building isn't massive, but maintenance costs can be. And if you are looking at a community college, maybe even distributed set of buildings across multiple campuses, to have your maintenance team have some remote visibility into the performance of buildings through their smart thermostats can save you rolling a truck out to a building. It can help you prioritize, maybe help you fix some issues remotely. We see that as a really key selling point and a benefit of these smart thermostats. The way we think about the functionality of controls for small to medium buildings, we kind of see this stairway, and we don't necessarily believe that everybody needs to get to the top step, but we certainly think that it would be great if nobody was on the bottom step here. So status quo in many buildings is just to have programmable thermostats. They allow you to get your schedules and set points adjusted. They're often wrong. If you put them right, they may end up wrong 6 months later. I think we maybe all have had experiences like that. So the next level of the stairway here is just to get the networked thermostat. So a smart thermostat, essentially. And there are many products within this realm. Just to have that communication, remote accessibility, centralized data collection, being able to visualize and monitor. The analytics and remote monitoring is generally not too sophisticated, which is kind of a benefit since many of these buildings do not have a large resourced operations team. So just being able to simply adjust and view what's going on in buildings is a significant benefit. Improving efficiency and air quality, if you go to the advanced level, that may take you into the realm of some additional sensors, let's say for CO2, additional controls hardware. You may have some more advanced analytics you want to layer on top. That gets you into the advanced realm where you have a bit more control, a bit more ability to guarantee occupant comfort, a little bit more remote diagnostics, etc. And then the top step, excuse me, the top step here is where you start getting to the grid interactive efficient side of things. So I'll talk a bit more about what that means. There's you know, a lot of things happening on the cutting edge, but I think demand response is very well established in terms of automating grid interactivity. I'm just going to flash up here an example. UC Davis has a program that they internally call Swarm. That's not the name of a off-the-shelf product. That's how they manage it. They have hundreds of small buildings around their campus. They had great control over their large buildings and wanted to get serious about the smaller buildings. So about 5 years ago, they started to replace standalone thermostats with networks. So getting to that second level of that stairway I just showed. In some cases, they've gone beyond to the third step and added some additional controls hardware, etc. And as you see in the benefits there, median 28% whole building energy savings. It really is very significant. And this is an example from an institution, UC Davis, that has a pretty long history of doing great work around energy efficiency. This isn't just they got great savings because they didn't know what they were doing. They just were paying attention to something that had previously not been visible. And this is just one example. I want to be clear. You see a Pelican wireless product on the screen. We're not endorsing that. There are many products. Pelican is just one of the great products out there doing this kind of functionality. There's a link on this screen here. If you go to the resources attached in the conference package here, you'll see this document here. Through the Smarter Small Buildings campaign, we've reached out to many vendors to learn a bit more about their products beyond the marketing speak that you find on their websites. And we've kind of classified the products into a few different buckets. And this is based on a couple dimensions. One is what types of functionality you can get from their products. The other is what kind of systems can they apply to. If you have a single zone packaged rooftop unit, there's a very wide selection of thermostat products you could choose. If you have multi-zone HVAC systems, if you want to also look at lighting controls integrated with your HVAC, then that kind of bumps you into a different class of product. So we're just trying to get a very simple classification here. We don't endorse them. We didn't approve them. We didn't test them. We're just trying to demystify the options that are out there, and we'll continue to add to this list as we engage more with the vendors that are out there. Another resource that I put in the best conference package there is this product selection guidance. You know, for you, if you want to improve the controls in your buildings, it can be complicated. And I think that this product selection guidance is really kind of a teaching people how to fish approach, where it's feeding you some questions and parameters that will help you engage internally on what the functional requirements are that you're really looking for. And then when you go out to vendors, you will be equipped to have the kind of conversations with them that will help you guarantee you get what you want. The call out in the bottom right here speaks to the two-way communication with utilities. That obviously is important if you're getting into the demand response realm. So that's something that's covered in that product selection guidance. And there's a whole lot more as well. That's just one little snapshot from that document. Okay, so got a few slides here about responding to grid signals. So what is the response? What is the kind of thing that you might want to do that's going to reduce your load and get you the big bucks in utility rebate checks? The most common would be to temporarily adjust, or AKA set back zone temperatures. That could be 2 to 4 degrees increase in occupied temperatures through the summer afternoon. Um, you might lock out temperature from being cooled for a percent of time. If you have multiple packaged rooftop units, they may be sequenced so that they don't all fire at the same time, which is what can really set some big spikes in demand. You can also adjust fan modes. And really, it's possible to configure multiple levels of logic. So let's say that you want to reduce demand over a 1 hour period versus a 4 hour period. You may want to take a slightly different approach in either case. So sometimes you start at level 4 and then you go to level 3, level 2, depending on the depth of load you want to reduce, and also the amount of tolerance you have in terms of your occupants dealing with potentially slightly less comfortable conditions. The last bullet on this slide here is just pointing to the fact that the control logic may pre-cool certain spaces so that when the temperatures are adjusted for the demand response period, you can kind of tolerate that for longer. So there's lots of variations. If you look at all the products, we recently reached out to 10 vendors that are offering these kind of functionality through their products. They can often do things slightly differently in how they implement, but it's variations on a lot of what you see on this slide. In terms of the control logic, you can go manual or auto. If it's manual, then what happens is that the thermostat have the control logic programmed in, and you kind of click the button on demand. So when the utility says at noon tomorrow, we need to call a demand response event, you would just manually program that to kick into that demand response mode at that point. The auto DR is something where the utility sends a signal and the thermostat automatically responds to that. And there would still be notice that would be given by the utility, so it's not a complete surprise, but it's something where the utility signal is automatically driving that. Um, um, what else would I say? So ADR 2.0 is the protocol. I'm not going to go deep into that, but that's kind of a known industry standard for that piece. But in terms of how that's implemented, it might vary from utility to utility. So configuration for any specific building and location would need some level of configuration. It's not pre-baked to the point where you just plug and play as such. And to the final point, often with these smart thermostats, the control logic is in the vendor's cloud. And so that's kind of the way that the utility signal goes to the cloud and then goes to your thermostat from there. In terms of the grid signals, just briefly here, typical historically, a utility calls for DR control from a given time for a given period of time. So maybe a 1 to 4 hour window. And that can be, it could be twice a year. It could be 10 times a year. It's of that sort of magnitude typically. There are some emerging approaches that are more using a dynamic utility pricing tariff approach, and whereby that, during a given day, the utility prices may spike up, and you may have a thermostat that then responds automatically and says, okay, well, when the price hits this point, this is when I ramp down the load through some control logic. If the price goes even higher, you maybe go to the next level of control. That's somewhat emerging, and HP Flex is a demonstration that Berkeley Lab is supporting to give some examples of that. And I have a case study of Bakersfield College here. This case study isn't specific to demand response, but it is an example of an organization, community college, that is participating with us on this HP Flex demonstration. I'll leave this up just while we do go to the Q&A piece here. Just a quick note, I mentioned the Smarter Small Buildings campaign. DOE is funding us to support any organization that wants to either improve the controls in their buildings that are conditioned by packaged rooftop units, or maybe they're doing great work and they would like to get recognition. So please reach out for us to us for that. And with that, I'll just jump to questions.
Thanks a lot, Elliot. It's always we're very impressed with everyone's timeliness today. We're doing great. So we have a question here from Steven. With smart devices for residential controls, is there a way to limit who has access to data when the manufacturer uh, is a service for monitoring and adjusting the devices? So how have you dealt with that with the members of the campaign so far?
Yeah, it's a great question. The Smarter Small Buildings campaign is focused only on commercial buildings. There are some similar concerns. I'll be my short answer is I don't have too much of an insight into exactly how that works. I think it's a valid concern. I'd be happy to follow up. But yeah, I think that's it's it's almost like the question we ask ourselves every day. We look at our phone and wonder who's getting the data that we are tapping into that. But yeah, I'm afraid I can't give anything more specific on the residential context there.
Oh, good. Yeah, and I think generally the conflation here, from what I understand, is just smart thermostats are seen or have traditionally been seen in residential, but bringing them into light commercial through this program, I think, is definitely a focus here. A question from Larry here: does the campaign have a list of thermostats that are well equipped for networking?
Um, We do. I mean, we have the listing that I referenced on one of the slides here. Again, that list is available through the campaign website and also on this conference platform. So those are products which, at the very least, have a track record of doing a great job networking. There will be others not on our list that I'm sure are good. We're looking to keep adding to that. But yeah, typically the way that would happen would be through a gateway. So the thermostats throughout a building or throughout multiple buildings might connect to a single gateway that is then either on the network or potentially has a cellular connection to the cloud. Yeah, they are a lot. Most of these vendors are pretty well experienced with that. It doesn't mean that you don't have to do your own due diligence around cybersecurity, though.
Yep, definitely. Cybersecurity and getting those wireless thermostats tied into the existing infrastructure can be a challenge for some, and it's definitely a consideration for folks looking to install those thermostats. Elliot, thank you so much, and I appreciate you taking the initiative and of adding the materials into the Zoom portal for those who are interested in the campaign. Please look to that. As well as contact the email addresses that are on the slide here. Well, Elliot, thank you once again for joining us and providing us some more information on the campaign and where you guys are. Everyone, thank you so much for joining this session. I would invite you guys to head over to the other sessions happening later in the day. I think we have Dr. Dong-Hoon Kim joining us in the next session. Elliot, thanks again. We'll talk soon.
You
See
bet.
you.
Thanks very much. Happy to be here.